Great. Good morning, everyone. Thanks for being here on our last shorter day. I think this has been a really good workshop so far, and I'm really looking forward to sort of continuing a lot of the conversations and the motivation that we've all developed over the past few days. So first, if I can advance, maybe. Let me just introduce today's goals, the vision, and some of the questions we'll go over in our breakout later, and then I'll summarize the breakout sessions we've had yesterday. So today the idea is going to be all about collaboration. So how do we work together to achieve all these goals that we've been talking about for the last 2 days? And in particular, we're thinking about requirements for joint infrastructure, which we've talked a little bit about, in particular JEDI, observation sharing, and diagnostic sharing. Opportunities for shared experimentation across communities and centers, collaboration between climate modeling and the data products communities and reanalysis producers, and then collaboration among the reanalysis producers as well. Oops. The first question we're going to discuss in our breakout later today is how can we develop a protocol for coordinated experimentation that can lead to actionable ways to improve reanalysis. And we will add in what we have there. Cool. Okay. So now let's talk about what we discussed in our breakout sessions yesterday. So the first question we'll talk about is opportunities and unmet needs regarding observational data rescue and sharing for a consistent reanalysis of the climate system. And we've sort of just put up a lot of things that each of the groups talked about, but hopefully we'll have a little bit of time for discussion that we can build on this after we summarize these. So first we talked about land use records for carbon cycle. We also discussed in our group the need for international coordination for data rescue efforts. So there is existing effort for conventional observations through the ACRE initiative, Atmospheric Circulation Reconstruction over the Earth. But there's no similar coordination for satellite, and that's going to be really important as we try to do early satellite and reprocessing efforts. We also need to focus on data rescue and create a database of air quality measurements and emissions to support air quality reanalyses. We need to look at tide gauges and ocean proxies. We need observation operators for those. We also need stream flow observations for land DA. We have a long data record, but maybe it's not as much of a priority and it requires a long development time potentially. There's a lot to be done, and ideally we'll share the load through enhanced collaboration. We need to find some organizational structure such as working groups to enhance that collaboration. And there's still a lot of heterogeneity at least in atmospheric data formats. There was some skepticism about different communities writing data in a getting different communities to write data in a common format. And potentially that would mean that we would need translation programs between different formats and orchestrating through some entity with enough resources and staying power. Sorry, a lot of the edits I think did not make it through, as seemed to have happened yesterday. Yeah, too bad. All right.
So, oh, I see.
Yeah.
Sorry, it's even rougher than I thought.
Yeah.
These are things I thought we corrected this morning. Maybe not.
That's
Okay.
Fine. Hopefully in the slides that get uploaded, I think this will all be updated and a little bit less rough. But we talked about needing a one-stop shop. So moving on now to opportunities and unmet needs for shared infrastructure, data access, sharing, and production suites. We talked about the need for a one-stop shop for reanalysis input, including observations, forcings like from SSTs for atmospheric, CO2 emissions, land use, fires, and versions of reprocessed data. And we also sort of discussed the separation between whether we want to have a data warehouse that's easy to access but maybe more limited, or a data lake that includes everything but is maybe more difficult to actually access from, as well as traceability. We also talked about ideally having a common infrastructure, or at least some easy infrastructure for sharing many things that we will need to share across communities and with users, including observation feedback, derived indices, bias estimation and quality control, consistent output variables, and potentially analysis increments and observation operators as well. We'd also like to exploit cloud computing for a lot of this and expand and support JEDI development for historical observation operators. We also talked a little bit about sharing the actual code for computing some metrics for the goals of transparency and repeatability. We also discussed coordinated experimentation via production suites to explore common technical and scientific trade spaces for developing and configuring Earth system reanalyses, for instance, coupling strategies and cadence, window lengths, etc. This also kind of crosscuts with the development strategies for a consistent reanalysis. There was discussion of the using shared infrastructure as a means of better entraining the academic community, especially for high-risk development and experimentation, that maybe the more higher readiness level groups don't have the opportunity to work on. There was discussion of looking to EU's Destination Earth project for a potential example or avenue of shared infrastructure and development, and I think we'll hear a little bit more about that today. And then there was some discussion of sharing teaching resources for data assimilation to support the development of the next generation workforce. And we've heard over the last few days that that can be a barrier to getting some of this work done, is not having people to do the work. And so next we talked about strengthening the connection between the reanalysis and the development of future observing systems. One thing we talked about in our group was expanding the definition of success metrics for future missions. So right now, a lot of our success metrics are defined based on what NWP success metrics are, and that's not necessarily what we want to think about when we plan developing future observing systems. We also discussed how we could investigate how the addition of synergistic or cross-component measurements in historic satellite missions could help improve estimates of coupled Earth system processes. So for example, observations at the boundary between two components. And how does this project on future needs for co-located measurements? And in that vein, we talked about specific observations that could be needed for some more coupled reanalyses, like PBL depth, vertically resolved winds, and more frequent observations of some variables like temperature, air quality, and fluxes in order to capture information on diurnal cycles. And I will let Ron take over from here.
Okay, so we have 5 slides, so we went 2.5 each. So split it right down the middle. So we had talked about moving on in terms of input into the future observing system, making sure that the reanalysis community is active and participates, leverages National Academy activities and equivalents, say in Europe, to make sure the reanalysis community data needs are represented. In our group, we talked about engaging with the private data companies and making sure there's a way and they're aware of the impact need for observations and reanalysis. For example, GNSSRO is probably one particular viable avenue. Since there are a lot of private data companies producing those observations, and they can be very reactive, those companies. Their bottom line is to make money, so they can they'll take feedback and act on it quickly. We talked about in our group the idea that reanalysis capabilities and the things we do are and capable of doing through reanalysis are great for identifying observing system gaps, quantities that are not well constrained, and even the deficiencies in our reanalyses that tell us about those things. Don't be afraid to use those to connect to, making the case for observing systems we need. So reanalysis can play a role with that. So let's see, detailed workflows for observing system sensitivities, OSSEs. So the climate community has specific recommendations through the essential climate variables, but no organizational structure in place to translate these for ECV requirements. And we talked about emphasizing the need for absolute bias and uncertainty characterizations. This is something that's come up through several of these topics. Okay, so moving on to strategies we can exploit to overcome the computational cost barriers to produce and monitor consistent reanalyses. Funding, okay, that probably can be on top of all of these. Just needing to make the case for the different development and reanalysis other than NWP as an essential climate service. Obviously, this is something that's happening in Europe. There was talk about trade-offs in terms of, keeping the computational costs down. The trade-offs between data precision for storage. Okay, I guess degrading the precision for storage can be very bad, particularly, for example, like greenhouse gases. So we need to sort of do work on trying to determine which components need higher resolution, which can be run at lower resolution, and have some sort of combination of this to keep computational costs reasonable, but accuracy at the levels we need. Metrics, of course, we need a good set of metrics for consistent monitoring between the centers. It would be great if we could share some of the, common metrics that are essential for reanalysis. And of course, there's already lots of metrics, and with the, combining these systems, coupling, that set of metrics is probably going to grow to huge size. So maybe we can do some work in identifying essential sets of metrics that all the producers can look at. The balance of production and storage of reanalysis in the cloud system versus permanent storage. I'm not sure I understand. Explain lossless versus lossy data compression approaches. So there's people, maybe someone can expound on that. Do you want to maybe go to the mic, Patrick?
So there was the recognition that there's just, with the increased model resolution going back in time, there's just a data deluge that's going to happen, whether to explore any types, and actually it's maybe not well formulated, but to use data compression techniques that could be, of course, the most ones that we like is the lossless compression, so that you have means to exactly reconstruct the exact fields, but also to explore the utility of using lossy compressions where you compress the data in such a way that the original data will not have the exact accuracy, but are still of sufficient utility to the community to users. But that the gain from data reduction would be so substantial that this should at least be explored.
Okay, thank you. Lossy data compression. I probably should know that. I don't. Thank you, Patrick. I guess we talked about in our group, and it came up in previous days, even in these plenaries, about the need to develop, the producers need to develop and support tools to facilitate data access from the cloud for users, and even to tools to transform data from, what are becoming increasingly, perhaps, I'll say non-standard, modern native grids, cube spheres, things like that, where we think it'll be efficient to put the data out that way, but not convenient for people to use it. Also in my group, we talked about exploiting machine learning and surrogate models where possible to mitigate the cost of some of the most expensive components of the models. If you're thinking about data assimilation, variational data assimilation, then the development of some of the adjoint components are either extremely difficult or intractable, and their costs to run, if you can develop them, can be prohibitive for some of the physics. So perhaps we can exploit machine learning for that. I guess, again, for computational cost barriers, to really increase our focus, the investment on software engineering to use some of the more advanced architectures that are coming along. I know, we and other groups are doing work trying to sort of get our models ready for the next set of architectures. They won't run there, well, not for operations yet, but we're making progress. We should invest in that. I guess there was talk about, are running reanalyses and simultaneous streams still going to be a viable approach once you have multi-component DA and weak constraints in some of the system components. We talked some of the early SARA experience from the Europeans showed that as you have these streams and you start looking at the deeper ocean, there's a lot of disjointedness. I know there are some comments that as long in our group that as long as you have estimates of the uncertainty surrounding those, that's fine. So hopefully we can still make use of that. And of course, there was the talk about the hierarchical analysis, families of related reanalyses. You don't try to do it all in one go. That's going to be prohibitive, but perhaps you have more, you know, a family of related reanalyses that are less complicated. And finally, and it's the yellow were notes to self that we actually took out. So I apologize again. Our edits this morning apparently didn't make it into this uploaded version. Okay, so strategies needed for consistent reanalysis. All of this was unedited, sorry. Perhaps start with uncoupled systems, of course, to get some sort of baseline that are carefully tuned first. And then, you know, so we sort of have a sense of what the coupling, this is fairly, you know, obvious, I think. Make sure your uncoupled systems run well, so you sort of can easily measure the impact of what coupling does. Strategies for sampling all sources of uncertainty. Again, I guess fairly obvious. For example, land use, radiative forcing, volcanic aerosols, things I guess we haven't, you know, the analysis community to date hasn't done a lot of, and you know, moving beyond some of the atmosphere and perhaps ocean stuff. This one, orderly process for model development across centers to support reanalysis. I think Laura and I saw that and said, man, we ought to take that out because we don't have an orderly process within our own organization, let alone across centers. So, okay, maybe we could, whoever talked about that, we can try to flesh that out a little bit to make sure we understand it better. A more systematic approach for quantifying uncertainty. Again, there's uncertainty. Yeah, increased investment. We saw a nice talk by Patrick about model bias mitigation. That's going to probably become more and more important as we couple systems that already have biases and then perhaps exacerbate those biases. Obviously, we constrain 40 VAR is one approach, but you're not running that sort of a system. In lieu of that, perhaps there's information to be gleaned just from the analysis increments, particularly in the systems that are the components that are most biased and easy to recognize, do something about those biases, the largest biases, just by simpler methods than say we constrain. Okay, one-way coupling for car. I guess we're just saying there's probably one-way. Carbon was an example here, and I guess this kind of comes back to the first bullet, the idea that, you know, you don't have to fully couple everything right off the bat, that you take this in a hierarchical way. I'm gonna skip the next one. Parameter estimation methods to improve model calibration, reduce persistent biases, and explore DA smoother approaches, I suppose, opposed to filter approaches, to provide consistent reconstructions. That's it. Like we said, it's pretty raw. It's even more raw than we thought it was going to be stepping up here, but we could certainly discuss this if need be, and we'll obviously massage it going forward. It's a lot.
So we have about 10 minutes for questions and comments before the next talk starts, if anybody has any reactions.
Thank you guys for your summary. I think one thing that becoming apparent to me as we're moving to the collaboration discussion.
Sorry, we're what?
As we're moving into the discussion about collaboration today. So, you know, sharing of observations and especially reprocessed observations is something that we've discussed for a while. But I think what I did not appreciate, because I was so focused on atmosphere and oceans, that as we add more components, there is more inputs than just observations. There is emission data sets, land use data sets, things of that nature, especially if we try to sample the uncertainty of that.
Yeah.
And I think that's probably a great place for us to achieve efficiencies, that we don't all develop different ways to sample land use uncertainties.
Yeah.
For example.
Yeah, that's an excellent point. Yeah. Yeah.
Nico Caltabiano, WCRP Secretariat. Also on observation side, the mention of the link of with the SEVs through GCOS and the need for a more international or an international link with, or that would translate to the observational network. This is something that in WCRP we can certainly play a role in discussing with GCOS, that with the communities, with the projects within WCRP. For oceans, for example, CLIVAR, together with the US CLIVAR, have always provide advice and modified the observing system as needed. So there is a role for the Reanalysis community together with WCRP to work on this. And we were discussing over breakfast about this, the coordination of international activities. That certainly is a role that we can increase this discussion.
Yeah. Just use the packet.
Kathy Smith, NOAA. Most of the suggestions look like they require sort of top-down organizing. Not all of them, but you know, to implement these things. And I don't. There's not an organization that's like that now that can do that. At least I don't think there is. Would that be something that would have to be developed, or would this all be sort of ad hoc, maybe coordinated through the various groups that already exist?
Well, I can also let Jeff and Sergey speak to this. I know, I mean, I don't think it could originate top down. Yeah, in the end, I think we're going to need a lot of upper management to support some of these big ideas. And I'm not sure that they necessarily always appreciate the magnitude of the undertaking. But I know the experience, at least we've had so far, is, you know, we're just trying to work with the people in the trench, like my counterparts, for example, at NOAA, and we're trying to sort of get our arms around sort of the problem where we have shared, where there can be shared activities, where we, you know, can do coordination and just sort of bring that up to our management, and hopefully that propagates to people who can, you know, help fund those things, whether or not there need to be overarching, you know, facilities or organizations to do that. I don't know, but certainly there's going to need support at high levels. I completely agree with that. Tom?
Tom Molinier, JCSDA. On the topic of performance and technology, do we have a good assessment of, you know, across the different Reanalysis production suites, the profiling, the hotspots? What are the performance bottlenecks, and if they're the same across the different current and future production suites? And the corollary question is, if, for example, I/O is a significant bottleneck, which I don't know if it is, but if it is, you know, could like a continuous in-core cycling DA alleviate some of that bottleneck?
I know we talked about in-core continuous cycling in our group for reanalysis, obviously. Yes, so I think the answer is yes, and we did talk about that. I apologize I didn't make it onto the slide, but we definitely did talk about that. Is there anything you want to add?
I mean, we didn't talk about that in our group, but I think that's, and I don't know. I mean, we don't have like a specific performance profile for our reanalyses. I would expect that things like in-core DA would help everybody, and that I/O is probably an issue for most. So there's things like that that I think would be common. It would be interesting to do a little bit more of a organized look at that for the different reanalyses to see if there's something else that's maybe more unexpected that could be solved. Yeah, that would be interesting.
I mean, we're doing simultaneous I/O as we're running, but even so, we're, you know, even if it's not costing you time, it's costing you cores to kind of do that. So yeah. The other thing you asked about was profiling. I will say that, you know, it's This has been difficult even for us to sort of completely profile and instrument the codes the way, I don't know that we have, to answer your question, at least we have we have a reasonable look at what our bottlenecks are, but I think we could actually do even a better job of profiling. I don't think we've done any kind of, comparison communication of that with other centers to know, hey, look, everybody's struggling on this piece. That would probably be excellent, because then there'd be obviously commonality that we could address. Yeah, very good points. Other questions or online? Jen, anything happening?
I don't see anything online.
Patrick.
Maybe I could add one more comment that was discussed in our working group, and that is again the need for the climate community within the reanalysis to get better organized and voice their needs, which is very well represented in the NWP community, and agencies, for example, that design new satellite missions or observing missions look to the NWP community, especially since they are that well organized. They have a lot of the workflows in place for understanding, quantifying observation impact and so on. In the climate community, that's not that well represented, and also some of the needs for climate monitoring are different to what they are in NWP, and having those requirements feed into the stream is important. And because reanalysis is in some sense a byproduct of the NWP community, that has to enter the NWP workflow potentially in order to then make it into the reanalysis workflow. So it's a kind of a convoluted, it doesn't go climate to reanalysis. It probably, maybe not, maybe I'm wrong, but it has to find its way into NWP workflows to then basically make their way into reanalysis workflows, depending on what exactly is meant by. But
yeah, and that was sort of what our group talked a lot about, and what I tried to get in here, but could have gone on every slide, is that I think we need to make the argument, and I hope that is one of the major outcomes of this workshop, is arguing that there should be that direct link between climate and reanalysis. Reanalysis shouldn't be something that just supports NWP. And we brought it up, as the climate crisis gets worse, I think there's an opportunity for us to argue that it is an essential climate service on its own, and ideally that there's resources to support reanalysis, not that we just get whatever's left over from NWP,
Should have started 10 years ago.
Oh, sure, yes.
Yeah.
Yeah.
Excellent. Yeah, definitely.
So since we're talking also the connection between the reanalysis and NWP, there's a nice link. A lot of what's developed in reanalysis inherits from operational NWP. The one thing the reanalysis doesn't have to inherit is the real-time constraints. And so there actually, I think, is a space where reanalysis could explore some things where you don't have to have a cutoff. You don't have to have time constraints that are so strict. And so you can allow to do things differently in how you select the observations, thin them, QC them, and so on. And that could be actually a really good pathfinder for NWP, because actually, let's say you assimilate more observations than NWP, you sort of show the path for and what NWP could do in the future.
Yeah. Yeah. I know just in talking with somebody like Dick D over the years, they, at the European Center, for example, reanalysis started off as sort of a separate thing, and then they realized quickly that it was basically not just sort of a byproduct of NWP, but something that was truly feeding back, learning so much about use of observations and data assimilation that it was informing the forecast development process. So absolutely, yeah. That's a lesson that's certainly something that we can exploit or use reanalysis to exploit.
Jenny, do you have any? Cool.
Nothing here. Yeah.
So I guess it is time to move on to our day 3 collaboration session. And I guess I will let Tom take over moderating.
Great job.
All right, good morning, everyone. So my name is Tom Morinier. I'm going to chair this session on collaborations, and we have great speakers from ECMWF and Copernicus and JCSDA. So without further ado, let me introduce Anna Shlyaeva from JCSDA, who's going to talk about the joint effort for data integration, simulation integration, and how it can actually serve a role for integrated reanalysis.
Thanks, Tom. Good morning and good afternoon, everyone. And thank you for the opportunity to talk here about JEDI and how JEDI can be used for the reanalysis. So what JEDI is, it's a joint effort for data simulation integration, and it's basically a collaborative effort between JCSDA and the partners of JCSDA on developing a unified data simulation system that can be used for different types of data simulation, and we can share as much as possible the development between different partners without imposing a single approach. JCSDA partners include NOAA, NASA, Navy, Air Force, and there are tight collaborations with the UK Met Office and NCAR here in Boulder. And most of these partners plan to have in the next 5 to 10 years JEDI be used for operational or near operational use, at least for some of the components of the Earth system data simulation. Right. Thank you. How can we develop and how do we develop a system that can be generic enough that we are able to use it in different contexts with different organizations that may have different requirements, but is also share as much development as possible and not redevelop some of the things. So you can think of this at sort of very high design level as we want to have a clear, and we have a clear separation of concerns in between 3 different things. So we want to abstract the data simulation algorithms from the specifics of the system that we're estimating, from the specifics of the observations that we're using to estimate the system better. So the key here is having this interfaces between these 3 components be clearly defined and then using them to in parallel developing all of those components. So if we talk about first of them that I mentioned, which is data simulation algorithms, currently in the system, we have generically implemented DA algorithms, so they don't depend on what kind of model you want to do data simulation with or what kind of observations you use. And we have a selection of variation algorithms ranging from 3D-VAR to the weak constraint 4D-VAR. There is an option to do ensemble of data simulations with various variation algorithms. And then there's the options to do LTKF and the gain form of LTKF filters. And the system is expandable, so we could add more algorithms or more features to the algorithms in the future. The next part that I mentioned is the observations, and that's a big focus at JCSDA because our mission is enabling faster and better use of the satellite observations. So the way JEDI works is we have this collection of the observation operators. You may have heard the term UFO, Unified Forward Operators. And the idea is that we develop the core of the observation operator once, and then it can be used by any model that is interfaced to JEDI. So this is just some examples of the observation operators that are currently implemented in JEDI. We have a couple of radiative transfer models. CRTM is actually a project also within JCSDA. And then Met Office and NCAR worked on that and interfaces door to toe. So it's truly a collaborative effort. Everything that I'm presenting has been developed not just at JCSD, but also the partner agencies. Multiple geosero operators. It's not just atmospheric operators. So we have marine composition, land operators, sea ice operators, and this sort of base of observation operators is being expanded, maybe not every day, but continuously. The third component, or the third of those big blocks that we can talk about, is the models that are interfaced to JEDI. So we have a range of models that are currently interfaced to JEDI, from toy models to multiple atmospheric models to a couple of ocean models, sea ice with limited functionality, land and composition. And if you think about this design of having data simulation algorithms, ops, and models, you can think of it as sort of plug and play approach, right? You can use the same model with the same observations, but swap data simulation algorithms, run LTGF or an ensemble of 40 VARs. And you can also swap the observations using the same data simulation algorithms and the same model. Or you can decide that I'm gonna run a 4D EN VAR with this set of observations, but I can look at how different atmospheric models would behave in this context. So now what I want to talk about next is how a system like this enables us to, sort of from the technical point of view, do coupled DA better. And I think that's an important thing to bring up here, because we've been talking over the past 2 days about different strategies to coupling and how that can help the reanalysis. So now we're talking about system. There are 2 points here. So one is, we've just talked about this concept of being able to swap the model while you're still using the same code for the data simulation algorithm and the same code for the observation operators. So if you think about it from this point of view, now you have a system where you can do an atmospheric data simulation, but you can also do an ocean data simulation, and you can do atmospheric data simulation with different models. And so if you take it a step further, then nothing prevents you from doing it with a coupled model, right? You can have an interface to the coupled model that would allow you to use JEDI with that. The second point that I'd like to make here is that we already have pretty wide selection of both different Earth system components. So we have atmospheric components from the multiple models and ocean components, land, sea ice, etc. And so from our perspective of trying to minimize the amount of development that we do between different centers, it informed us to work on something that we call sort of generic coupled layer. So, which can get you pretty far with doing coupled data simulation. The idea here is, if you want to do a coupled DA with a coupled model that, let's say, includes atmosphere A and ocean B, and you already have interfaces, separate interfaces to atmosphere A and ocean B, then we want to use what we already have for these model components to do the coupling at the generic layer. And then if somebody else wants to use atmosphere A with an ocean model C, again, they don't have to do an extra development to do that. They can use this generic layer that allows you to do the coupled data simulation. There's this genericity, of course. There's a point at which it makes it, things are harder to keep generic, but we feel like we can go pretty far with this generic layer. I was inspired by Sergey's talk yesterday, talking about different strategies to coupling and sort of showing it through different terms in the cost function or the Kalman equation. So I'm kind of riffing off this here now. So just talking a bit about the plans for coupling using JEDI. this design of the code that I talked about with the separation and abstraction of models, algorithms, and observations, it makes coupled easier from the technical point of view. Of course, there are still lots of scientific questions to answer, right? But at least it enables you to do, to start answering this scientific questions using this environment. Just listing a few steps here. So having weakly coupled DA, so coupling through the modal, that's possible now, and it's not a JEDI feature. It's pretty much at this point a feature of any data simulation system. You can just run your coupled model outside of DA and do data simulation on various components. Something that we're working on now is the enabling coupling through the observation operator. And that's where this concept of separating or having a clear interface between what's obs and what's models comes in very handy. So I think it's a feature of JEDI that makes this fairly easy technologically. Next steps would be coupling through the background error covariances and including the cross covariances between the components, coupling through modal within the DA executable. So that would enable you to do things like coupling through the outer loops, and then things that I didn't put in here, but doing the coupling through the joint if you're doing the for DVAR, a joint of the coupled model, and then one can probably think of coupling through the Q matrix in the weakly coupled, but that's beyond the short planning horizon.
4 minutes.
Thank you. So there's a lot more than this coupled DA development that's happening at JCSDA for the JEDI. But I wanted to bring up in particular two things because they kind of resonated with me with the discussions that I've heard and had over the last couple of days. So one thing is, so now we're in this position where we have a system that can be used with different models, different data simulation algorithms, simulating different observations, and we'd like to be able to efficiently collaborate with people who are using this system. So one of the things that we're sort of spinning up this year is this JCSDA ecosystem Skylab. And a couple of things that I think are relevant to the reanalysis discussions that we've been having is this idea of having, we call it Research Repository for Data and Diagnostics, or R2D2, database on the cloud where you would have the observations. You can spin up the experiments using the workflow that is currently being developed at JCSDA. And then you can sort of put the results of these experiments back into the cloud, into this R2D2 database. And then we'd have the diagnostics, some of which could be pre-computed, the others could be computed on the fly or be interactive, and have this common diagnostics for easy comparisons of the experiments and collaborations on that. And then another thing that resonated with me is, I think it got brought up this morning in the summary, but also by Ralph at the talk on Monday, is the training of training of people. So we have some efforts at JCSDA for the education and outreach. We've been running JEDI academies for the last 4 years, which is sort of a week of lectures and practical sessions on JEDI. We are spun up last year a project, which is a collaboration with the CSU on what we call JEDI EDU, and that's basically a set of tutorials that can be used for teaching data simulation either at universities or at summer schools or things like that. And they would use JEDI with toy models and then progressively move to using JEDI with more realistic models and realistic observations. And then my hope is that we can, especially moving into this world where I can speak here, not just in front of my computer at home with my cat, I hope we can have an active visitors program and regular hackathons. There are multiple ideas of what we can do in person both with the partner agencies, but also involving wider community, academia, and to have this vibrant community of people working on JEDI. And a couple of thoughts on the questions, on some of the questions that I got asked. Some of them, I did not see the slides that Laura was showing this morning, but some of them are pretty similar to what she talked about. So I'd really be happy to see some progress in coupled DA and with various degrees of coupling between various components. From my experience, a couple of years ago, I worked with Jeff Whitaker and Tom Hamill on running the reanalysis for global atmosphere at NOAA. And I think it would be really great to have a shared and easy to access observation database that's well documented. That could be responsibilities could be shared between Fourier processing and adding data. And then on the other side of the production, it would be great to also have a database with the reanalysis and kind of things that we're talking about this morning. And then since it's a collaboration section, and the question on the collaborations about which collaborations are working and which need to be fostered, and I'm kind of following Laura's lead here by asking a question instead of answering a question. Maybe it's a question to a sort of subset of people who have experience working with JEDI here. So are there some things that can be learned from this collaboration that you've had with JEDI? And an additional self-serving question from me is, are there things that we should improve when we collaborate within JEDI? So thank you.
Well, actually, that's a very skillful way of starting the questions with a question to the audience. So I don't know if anyone wants to tag along with that last question that Anna had asked at the end of your talk. Are there any reactions or questions for Anna?
Thanks, Anna. It was very nice. My comment was, the question was going to be about another slide, but yeah, I think the answer to the last question is there's obviously a lot can be learned. Some things have gone very easily. We've learned through JEDI in terms of collaboration. Some things have been a little more difficult, even though you guys have tried everything you can to get us to do it. But so I think the answer is yes. I don't know if it's worth articulating those right here and now, but yeah, for sure, at least in the US, this is one of the, probably the largest collaborative attempts and this level of complexity that we've tried. So I'm sure there's lessons to be learned. Can I ask you to go back a couple slides if you can navigate? Oh, great. There's a nice picture. Yeah, to the JCSDA ecosystem slide. There you go.
Thank you.
So, right, this is essentially, the Skylab vision, for example, and the blue box there on the bottom is, your workflow. For a number of reasons and necessities, some of the groups who are using JEDI are, like in our case, we have our own lower blue box, but we're building that around, R2D2 for the in and out. So, I don't know if you want to consider that separate from this environment, or maybe there could be a version of this slide with external workflows that still hook into R2D2 and then take advantage of all the stuff on the top. I don't know, but anyway, so we may get to this eventually for all the groups who are using JEDI, but right now some of us are replacing have our own bottom blue box, and I'm just wondering about your views on that. And
my personal view is that I agree with you that there's a lot of value in this LON R2D2 blocks plus the diagnostics and the ability to do the real time ops ingest. And for me, I think about things modularly, maybe as a nature of this job. So I do think that you can have multiple blue boxes down there. But that's my personal opinion. Maybe Tom can talk to JCSDA vision.
Yes, I mean, there's no issue with having like various workflows that sort of hook up at, you know, it's not necessarily like a take all or leave, you know, it can be very modular. The advantage of that blue box is it can be also used as a way to emulate external systems, and so reduce a lot of the support, maintenance, help on a variety of the deployments down the line. So it
Yeah,
doesn't mean that agencies have to adopt it at all.
Yeah, if I might, I totally agree with that. Our blue box would be something that's very, you know, be high resolution. It's our system, you know, it's the thing we're running, the big system, for example. You could emulate I know that the vision is to emulate things we do at lower resolution in your blue box that would then be easily importable into our systems. So yeah, I totally understand that. That's how hopefully we will benefit from Skylab, for example.
Thanks for a really great presentation on the vision for JEDI. But I was wanting to ask a few questions about that coupling component. So you had the equation up there with the different pieces where you could do the coupling. The one back. I was curious about the M and the X sub K. So in that formulation, X sub K implies a specific discretization common to all elements of the state. But in a coupled system, I might have very different timescales related to different parts of the M operator if they represent different components of the Earth system. So I was wondering how, I mean, I'm sure this is just for illustrative purposes, but could you comment a little bit more about how you might factor M and factor X that will allow for different time steps related to different X's, how they might be then jointly related at M as M evolves, if M is now essentially a dual component, so an M operator for atmosphere, M operator for ocean, an M operator for land surface, all running at different time steps with different parameters that might be constrained. How might you, in a software standpoint with JEDI, begin to tackle how you would couple those pieces together?
Right. So I think if we're talking about coupling, and yeah, it's a very illustrative example, right? So I think within the JEDI context, we're going to be talking about propagating a coupled model from time tk to tk plus 1. And that this is not a time step for any particular model. This is sort of your data simulation step, if you wish, and not in terms, again. So it's how often do you want your data simulation system to see a coupled state? So it may be that you, within that step, you may want to be able, all of your components to propagate in time and have the coupling sort of inside the system, right? So that's sort of your decision. From the software engineering point of view, I think this is where it becomes a little bit harder to be generic. And so I think this is where my vision is, if you want to do the propagate the coupled model within the data simulation system, then you should use the option where you still use a lot of this, idea of having this things like a coupled state, which is basically just a collection of states. So you use the generic development where you can, but where you have to be specific, and it's a specific coupled model that is coupled in a specific way, and you need to propagate from time 1 to time 2. This is where you call the specific coupled model using the generic coupled states as the interface pieces, if that makes sense.
But wouldn't that might imply that you might literally be running like 3 layers of assimilation? You could have a coupled system that's assimilating points, and then the other parts that you're not exposing to the interface of the coupling, those are moving along, and those could be being assimilating data at the same time. In other words, if you have two models that are coupled, some components of that system could be constrained without being coupled.
Right.
Could be coupled. And so if you had two systems, you might have literally 3 layers, uncoupled on M1, coupled in M1, M2, and uncoupled on M2.
Yeah, but you can also think about it if you're propagating in the time step where your one model component changes, but the other one doesn't because its time step is longer than that, then you're still doing the coupled data assimilation, but you're basically just updating one of those components. I think that's technologically that's possible, yeah.
Thank you.
All right. Well, thank you very much. We need to move on to our next speaker. So let me introduce Anabelle Guillory from the Copernicus Climate Change Service. And Anabelle is going to present how user requirements are actually affecting RF5 production.
Yes, thank you. Hi, let me share my screen. The one, right? Okay, hopefully you can all see my screen. So, hi everyone. Yeah, good. Okay. So first off, thank you for giving me this opportunity to share with you how user requirements are driving the evolution of ERA5 products provided by the Copernicus Climate Change Service at ECMWF. I also want to say that I've prepared this presentation with the support of 2 colleagues, Hans Hersbach and Paul Beresford, both in the Reanalysis team at ECMWF. So let me start first with setting the scene a little bit and explaining, giving you a brief overview of what the Copernicus Climate Change Service is. So basically, it's one of the 6 Copernicus program-funded services dedicated to climate. So it's essentially transforming all these observations, satellite and in situ observations into value-added information about the past, the present, and the future climate. So it's a trusted source of climate data, tools and information at global and European levels. And it's to enable climate mitigation and adaptation strategies by policymakers, businesses, citizens, and so on. So there are really 3 things I want you to remember about what the C3S, what we call C3S, the Copernicus Climate Change Service is. First off, it offers free and restricted data access. It's sustained and operational service. And perhaps one of the most important things right now that you need to remember is that it's user-driven. And to support the implementation of C3S, we have the Climate Data Store, the CDS. So this is the cornerstone infrastructure of the C3S. It's really at the heart of C3S. And basically what it is a one-stop shop access to quality assured climate data information tools and good practices. It's a distributing system offering access to over 130 data sets, essential climate variables, climate analysis, reanalysis, of course, projections and indicators. And we have right now over 130,000 users, and it keeps growing like crazy every day, and of which we have 80,000 users for reanalysis. 76 terabytes per day downloaded either through the web interface of the CDS or programmatically using the API service. And the great thing about the CDS, as I mentioned, is a one-stop shop. So it comes with the data that's available in the CDS comes hand in hand with the toolbox. I'll come back to that in a minute. User support service and an evaluation quality control service, the EQC service, which will become, which I'll talk about a bit more later on. So the toolbox is actually a set of software tools allowing users to develop web-based applications that make use of the datasets available in the CDS. So essentially, you know, we have big datasets. We're talking about very large datasets, and the idea is for users to come along to the CDS, use the toolbox, manipulate the data they want right there on the CDS, and download the output, the results on their local machines. So, of course, the CDS holds the ERA5 global reanalysis. My colleague Chiara showed this slide actually earlier this week on Monday, I believe. So I'm not going to go into details, and I'm sure all of you know more than me perhaps what ERA5 is. So ERA5 is in production, of course, at ECMWF for C3S, and it has replaced ERA Interim, which stopped being produced at the end of August 2019. And it brought some great improvements ERA5 brought some improvements compared to ERA Interim, of course, in terms of high resolution, hourly output versus 6 hourly output we had with ERA Interim, and uncertainty estimate. And of course, the big thing with ERA5 is that it's produced and made available close to real time with a latency of 5 days. And it reaches further back in time, 1950 versus 1979. So the ERA5, of course, is made available, as I mentioned to you just now, in the Climate Data Store. Again, we have a really nice, consistent way of presenting all our data sets in the CDS in a similar way. So we have an overview page explaining what the data set is, what are the main characteristics. And as I mentioned before as well, it comes hand in hand with user support. So what we mean by this is all the information that's related to the data. So the documentation, of course. We have extensive documentation for ERA5, guidance on how to download data. This is really important to make for our users to make the most of the data. And it comes with the quality assessment reports as well. This is the EQC, Evaluation Quality Control function of C3S I mentioned before as well. And from this page on the CDS, on this overview page, of course, we have the link to download the data. So this is a really simple, nice way of presenting how a complicated dataset can be downloaded for users. It's a simple web interface, a download form where you tick the boxes and submit the form, and you get the data you want, hopefully. So one thing that we were able to do when we made the ERA5 data available through the CDS was actually a simplified data presentation. So you might recall, for those of you who used ERA Interim, that to get ERA Interim, you had to specify whether you wanted analysis or forecast. In other words, instantaneous parameters or accumulated parameters, the date, the time, the step. And the accumulations were done from the start of the forecast. This was incredibly confusing to users. They had real difficulties understanding, what's analysis, forecast, how to accumulate their parameters, and also because it was accumulation from start of forecast, it's difficult to use for them because you don't get the hourly update. So you have to remember that you have to subtract the previous accumulation up to the previous hour. So it's incredibly complicated. So when it came to ERA5, there was a change made for this, and this was implemented nicely when it's presented on the CDS. So now when users come to the CDS to download ERA5 data, they only need to specify the date and time. Basically, the information, the analysis and forecast fields are still there, but it's hidden from them. So they don't need to think about whether it's analysis or forecast. And the accumulations, that was a big change as well, is done on the last hour. So, and min fluxes were made available as well, because that was another thing that was complicated for them to work out. So it was a nice thing, a nice improvement made in terms of data presentation. And of course, we had this change in terms of accumulations done on the last, at the end of the forecast versus the start of the forecast. So all this information, of course, was fed through to the ERA5 production team via user requirements, via user input, via user feedback. And this is collected essentially through the user support. So you're still in the reanalysis talk, okay? But I'm going to try to get your attention on what the message I want to get through here. So when you think about a turntable, okay, a music record on the turntable, you have your people wanting to listen to the music, okay? So you have your turntable ready to go, and you have the record, okay? So the record here is our data, okay? It's ERA5. And of course you have a producer, right? The label of the record. Now you want to get this data and you want to understand this data, you want to hear the music, okay? So for that, what do you need? You need to get it going. You need this ARM thing to actually get to read the information on the disk. Well, this is the connection that we're making. This is what is connecting the music to the spectators, to the users. So essentially, this is the role of the support team. It's really connecting the users to the production team behind the scene, if you like. So this is really the channel through which users can give their feedback about the reanalysis. So the user support team is really in a prime position to collect all the feedback from users and any issues they may encounter with the data, and turn to the reanalysis production team, of course, to pass on the information and for following up. By the way, I'm in the user support team. I'm pretty sure you guessed this by now. So the user support team, of course, why is the user support team so important? Well, first off, because we deal with users all the time. We have a broad knowledge of ERA5 and other C3S products, of course, and more widely ECMWF activities. We have an extensive experience with handling user inquiries and problem resolution. So we can tell when it's only a question of documentation or there's something a little bit more that needs to be investigated and passed on to, checked with a production team. And of course, we have a really close working relationship with the technical teams, that would include the Reanalysis team, of course, at C3S and some others as well. So the user support is really like a channel, if you like, a fast-track channel from users' needs to the technical team. It's like an open door for getting the users' input and passing on to the technical team for their consideration. So, of course, down the line, this means that we're implementing essentially data products and could satisfy the users' needs. So here's another example whereby the user feedback was collected and put back to the production team. So in this case, it's actually, I'm going to explain first about the ERA5 timely updates. So we have many users always asking for timely updates in addition to the consistent long climate record. So the ERA5, the reanalysis data is made available, the validated, the final product is made available 2 months in arrears because we need time to validate the data, okay? But the users are always asking for data from tomorrow, or yesterday, rather. So for this, we could not guarantee good quality control. So the production team came up with the idea of having the ERA5T, what we call the ERA5T, which is preliminary data, made available 5 days behind real time. Each day, 1 day is added to the CDS, and 3 months later, or 2 or 3 months later, 1 month of the final product is made available. So this allows for correction if required, of course. In the meantime, the data is exposed to the users. So this service was introduced in December 2019, and since then, each month, the ERA5 validated final version overrides the ERA5T, the preliminary version, okay? Then in October 2021, some users reported a strange-looking anomaly, erroneous wet blob of soil moisture that you can see on this plot in particular. It's pretty obvious, and it was found north of the Caspian Sea. So it appeared to be related to assimilation of pool snow observations, and it was decided by the production team to withhold the station and a few others actually, and to rerun. So they did this, and that meant the final ERA5 products was corrected in time because it takes 2 or 3 months for ERA5 final version to be published. So later on, of course, the general quality control for snow observation was improved in ERA5T. So this is showing a great example of how integrated the production for ERA5 is, because we can really we can have users reporting issues, sending them feedback, and the reanalysis team has a fast turnaround, can react very quickly to make changes as needed. So we have, as I just explained, so this was an issue reported about this snow anomaly. But this was just one occasion, okay, reported through support team, fine. But as you can imagine, we have lots of users, and reanalysis data is one of the most popular, if not the most popular data set at C3S. And we're getting hundreds and thousands of user requirements and people sending them feedback. So we need a little bit more than just user support to be involved here. And we have this EQC function at C3S, the evaluation and quality control, which can help with this. So the evaluation and quality control at C3S, it's basically looking at it's a quality assurance service, okay? So it's looking at the CDS data sets and looking at their fitness for purpose, and is also doing independent assessment of the data sets. It's looking at the CDS toolbox, assessment of maturity and fitness for purpose of the software provided to explore the data sets. It's looking at the CDS service itself, its performance, of course, and in terms of speed, responsiveness, and how available it is. And then, which is of most importance here for us, is looking at the CDS users, and in particular, looking at collecting the user requirements from various sources to ensure user-oriented evolution of the CDS and beyond. So on this figure, you can see how user requirements are collected. So yes, user support is part of that because we get an awful lot of feedback and user requirement collected from that end. But there's other channels of other sources of user requirements. They're focus groups that they organize. We have the forum on which users can interact with one another, and there are questions asked and user requirements can pop up there. There are workshops organized, and of course, there are emails and indirect interaction with users. In addition to this, as part of the assessment of data sets, toolbox, overall service, and interaction with the sectoral information systems, which Karen mentioned earlier this week, there are feedback coming from different sources. All of this is put together into the user requirement database. We call it URDB. And as you can imagine, there are thousands. In fact, I think there are about 4,000 requests at the moment, user requirements at the moment in this user requirement database. Not all about reanalysis, okay? This is the whole C3S service, but nonetheless, an awful lot about reanalysis. And then the function of the EQC team is to look through this URDB and analyze the user requirements, put some together, and have some actionable recommendation that they put together in the user requirement analysis document. So it's all very nice. We have a lovely document, but we need to do more after this because we need to act on this. And we've come up with this process in C3S whereby we really collaborate between teams, and this results in can result in product and service evolution. So again, the support team is very much involved in this because we're facing the users all the time, and we know how they work. So we have the EQC team reporting from the URDB and URAD, the analysis report, reporting the user requirements and the recommendations through a support portal dedicated for them. And so these are like tickets created basically on which we can act. So the support team receive this, review the tickets, and so on there we can quickly, maybe some we can act on it ourselves, and some that would need the involvement of technical team and production team. So when we have tickets, user requirements or recommendation that need the input of technical officers or production team, we review that with them and we put a recommendation together for the next stage of the process, which is the EQC review board. So the EQC review board, it's a group of people that include the C3S management, the representative of support team, representative from the CDS, the Climate Data Store, representative of technical teams, and I think I forgot one, and I can't remember which one, but it's a group of people who can discuss and approve, and this is key here, approve or reject. They make a decision on whether or not the request has been forwarded to them can be implemented or not. And this is based, of course, on various criteria, including resources, whether it's a critical request or I mean, there are different criteria, okay? So if the board decides, yes, we go ahead with this and we're going to implement it, then of course we go ahead, we have a task, time-bound task set, and the technical team or production team has has to act on this until the task, the request is implemented. And of course, after this means product and service evolution, right? So again, in this process, which works really well, the key thing here is a decision maker. This is what we need to get the momentum for things to happen. Without this, it just wouldn't work or it wouldn't work as efficiently. It would be like walking on 3 legs, okay? So the decision maker is key here. And in the end, it makes our users happy.
Start wrapping up.
Okay, so really quickly, this is another example, really nice example of a user requirement that came through this process I just explained. So we had lots of user requirements because the reanalysis data is made available hourly and monthly. And guess what? There's too big of a gap. Users want daily, of course. So there was no way we could implement this with the reanalysis data like this. So the proposed solution was to use the CDS toolbox to generate the daily data on demand for users, of course. So the tool is there for users as part of the CDS to obtain ERA5 data aggregated at daily frequency, of course, without having to download the original sub-daily resolution data, which is great. It's actually the most popular tool right now in the toolbox. User demand is satisfied. There's, of course, on top of that, the toolbox, the nice thing is that the toolbox is exposed and we can show its potential to other users. And then with the toolbox, the source code is available too. So users can do more things than this. So I'll pass this really quickly because I think Carlo will mention this anyway in the next talk. But of course, as part of this EQC process I mentioned earlier, where we have the decision maker, sometimes there are requirements, and in particular for reanalysis, whereby we know we can't implement immediately. So we put these requirements on a wish list to be reconsidered later on. So we have a few at the moment for that we came up for during ERA5. And we want to look at those again for ERA6. So I recap really quickly. So I mentioned the Copernicus Climate Change Service. It's user-driven. This is really key. And of course, it's free data for smart decisions, okay? And then I mentioned the Climate Data Store. That is the one-stop shop, okay? So this is important. This is where we have all our quality assured climate information. And I mentioned the support team, remember the turntable, how important it is to make the connection between users and the production team behind. And the EQC service evaluation quality control, again, helping in the process of collecting all the user requirements because support team alone can't do it. So again, you know, all these services, the CDS, the EQC, the support team, and of course, the production teams, the data producers, they cannot work independently on their own making decisions. It has to be a collaborative effort. This is how it works. This is really the recipe to C3S success in driving the evolution of reanalysis products. The ingredients, we need focus on users. And of course, we need an operational service, something where we can react, like I explained earlier. And the method here is to govern collaboration, what I explained with this EQC process, whereby the user support team, the EQC process, EQC team, and the production teams work together to really make this happen and have user requirements implemented in a very efficient way. So I think, and this will be my last thing I say. I think at C3S we can be very proud in what we've set up with, you know, to have this collaboration, this strong collaboration between the support team, the production team, the EQC team, and the CDS team to make this happen and to drive reanalysis product evolution, ultimately, of course, for the benefit of our users. So I'll stop here. Thank you very much.
Thank you very much, Anabelle. That's a great example of a user-driven product development approach. We have time for a very quick question. Yes.
Kathy Smith. I was curious about sort of naive users. For example, finding out what a reanalysis data set is. If you go to the page, you see like documentation for ERA5, but knowing what it is, I think a lot of people don't know what a reanalysis is. And as part of that, how do users know that there's like an error bar throughout time and that the error bar expands? And so how would they apply the data, in their products, knowing not getting an error bar? Is that an issue? And just one more quick question. Why not supply some of the daily data just for some variables that are common? Usually there's like about 10 or 15 that people always want. So I was just curious about that. But the error bar is what I'm particularly interested in.
Yeah, I'm not sure I understand the term you use, actually. I'm sorry. As for the daily data, I think Hans, who I think is online, will probably better to answer that one because I'm the support team. I'm not the producing part of the producing team. But I'm not sure I understood your first question. If you could try again, sorry.
Carlo.
Users don't know exactly what reanalysis is. I mean, I've had that experience. I think it's measured data a lot of times. And so they don't necessarily know how, maybe how to correctly use or interpret it.
Right.
And especially they don't totally get the idea that it's not that there are errors. I mean that there's a range of values it could be within, and that range increases as you go back in time.
Yeah. Absolutely.
And so you get the idea that this is data as opposed to, this is a space of data or something like that.
Right. This is why documentation is key to try to really reach out to a really wide range of users, because this is what we're dealing with at C3S. And in fact, it's interesting you mentioned this because we're already thinking of, at the moment, we have a really extensive documentation for Euro 5, but it's kind of, users look at this, it looks complicated, okay, for users who don't know what reanalysis is. So we're already thinking of changing this so that we have different levels of documentation, so that you have like steps, for somebody who doesn't know anything about reanalysis, they have a kind of more basic documentation versus somebody who knows everything, almost everything about reanalysis, will have a different type of documentation. So we're already looking into this. But yes, I mean, I mean, again, the support team, when we get requests, we're able to work out, who we're dealing with. So we're in a position whereby we can support users as best as we can, and we can pretty much quickly understand what level we need to help them out.
There's a comment by Carlo too. He says, I will say something more related to this question in my talk. So maybe that's a good segue to go on to Carlo, and then we can table this during the discussion if we don't tackle it in his discussion.
Perfect segue, indeed. Yes. All right. Thank you very much. So we're moving on to our last talk for this session, also from ECMWF Copernicus, but I guess it's a different turntable. So it's the Destination Earth and the digital twins. The presentations from Carlo Buontempo and Peter Bauer.
Thank you very much. I took the liberty to slightly change the title just to make it more relevant to the discussion. And I also realized that being one of the last to talk and one of the last from ECMWF to talk is going to be hard to mention something that has not been mentioned already. So indeed, I will cover the C3S part, and there are a few slides on Destination Earth at the end from Peter Bauer, who leads the Destination Earth program. And the slides, as you will see, have a lot of contribution from the entire C3S team and beyond, including Hans, Chiara, and Anka, and Bill that you heard during the workshop, but also from Irina Sandu, who is the lead scientist on Destination Earth. So, well, in a sense, I think I can start from a bit from where Anabelle has left, because for me, one of the key elements, and if there is a take-home message from our experience, is the fact that we are serving a community that is very wide and goes way beyond the climate community or the NWP community. And I will show a few examples in a minute. And in order to serve that community well, as Anabelle show very nicely. Actually, the user support and being operational in the true sense of the word is key. And what I mean by that is that it's not just delivery of high quality data in a timely fashion, in a predictable way, but it's also to have all these ancillary and accessory but essential elements such as user support. The last point that we were discussing during the Q&A after Annabelle's talk, I think also maps to another element, which is the one of training. And training is very important to us, and is one actually of the area we have expanded on. So for those users who are not necessarily familiar with Reanalysis, training module, Jupyter notebooks, and the like are being prepared to support them. And as one of the results of this effort, which goes beyond Reanalysis, is the feedback we collect from the users. And clearly I showed a nice one, but generally the users are very pleased by what we're doing. And the user satisfaction is quite high, and there as you would expect, is a U-shaped distribution with very positive and some very negative one as it happened, because there is a self-selection in the process itself. You have seen some extraction of this slide before, and there are a few points I want to make here. One is that, and this has been made very eloquently by Anabelle before, that basically the vast majority of our user, more than 50% in fact, are user of Reanalysis. So if you look at this nearly 500,000 data requests we get every day, then even in terms of request, the majority of those are from Reanalysis. I picked, this is a snapshot of our live page, and if you're interested, you can scan the QR code on the top right, and this leads you to the live page where this information is available. I picked a date that is unusual, so if you look at the data set on the top right here, you have a variety of data set. ERA 5 is always on top, no matter what you do, but in this specific day, which I think was a couple of days ago, we had also the projection, the river discharge, the regional analysis for the Arctic, and the seasonal prediction, which is, as I said, is not the most common. While the first two are always ERA 5, often also the following three are ERA 5. It's not the most common, but it's an important one, because one of the elements I've been making all over and over again during the breakout session is the fact that one of the key elements in order to serve this community of users is caring for the interfaces. So while the majority of users are users of ERA 5, they are not using only ERA 5. They're using ERA 5 in conjunction with other data sets, such as, for instance, the projection. So being sure that at the data level, for instance, the example of precipitation accumulation is a good example. These data sets are compatible with one another is key. Chiara also show a nice example of application. I want to show a few more here. Bottom right, the colorful image that you probably see as big as a stamp is an example from a small enterprise in Spain who has developed a very nice, it's called Lobelia, the company, and they have developed a very nice interface to ERA 5. It's not commercial, so in the sense it's free, you can use it, and they use it a bit as a shop window for their pay products that are mostly related to agriculture, but it works. It's very interesting, and it shows the innovation that happened downstream of us on how the data can be used. The one in the center, which is a sort of a diagram, is a diagram behind the approach used in the Global Wind Atlas. This was funded by the World Bank. A lot of the design was done by the Technical University in Denmark, and the implementation was done by another small company called Vortex that operate on wind resources. So a couple of examples showing the kind of user we're talking about here. Yeah, and I want just to go a bit deeper on Vortex, on this company, because they put together this nice infographic for us. So actually this was done by them, for them. It's entirely independent of us. And they're using, in this case, WRF to do the downscaling of ERA 5 to very high resolution, and then an LES for the microscale. They come up with some number of what it means having better Reanalysis that I thought were interesting. So they estimated the amount of energy generated by a typical wind turbine, the sort of capacity factor of this wind turbine, and what it means to reduce the annual energy production error by 1%. And this translates for a typical installation in the hundreds of thousands of US dollar per year. And if you look at the installed capacity worldwide, then this sums up easily into the hundreds of millions, which I think is interesting because the kind of benefit they claim ERA 5 brought to their business could, in terms of absolute energy production, annual energy production, is in the order of 3-4%. So, yeah, okay. But this opens also a question, and you have seen this slide before, or some sort of this slide, and this is the temperature anomalies of ERA 5 going back to the 1950s, where you see a number of discontinuity. Some of those, and this presented in this slide, are related, especially in the stratosphere, are related to major volcanic eruptions. You also see El Nino and of 98 and 2016 and stuff like that. But as it was picked up by many of the speakers before me, and also in the discussion during the breakout session, we know that some of these this transition, this discontinuity, are not genuine. And so this is, for instance, the example of what's happening in the stratosphere. In the stratosphere, those discontinuity are particularly noticeable. Clearly you see the introduction of the GPSRO in the late 2000, but you also see the transition from NOAA 7 to NOAA 9, or from TOVs to ATOVs. So this is to say that there is complexity in the data set, and a bit as the question at the end of the previous talk was sort of suggesting, we need to be sure that these information are provided to the user effectively. And this goes back to what Anabelle was mentioning, in that as part of the quality control, or EQC, evaluation quality control, one element is to do the quality control and to ensure that what we put out is of good quality. One element is to collect the user requirement, that was presented very nicely, but one element is to enrich each catalog entry with sufficient data or quality attribute to allow the user to make an informed decision and use the data in what we think is an appropriate way, or at least an informed way, let's say. So these are the kind of steps that the dataset go through. So the basic check, the dataset maturity, in some cases the fitness for purpose, and then some summary information. So just what it means in practice, you see here on the left is a distribution of the ERA 5 land monthly means to meter temperature, and there are some, as you would expect, limit of plausibility for rejection of the data. It's important, or at least flagging the quality of the data. It's important to say that these elements are not done by us directly, are done independently from the producer of the data, and are done throughout the entire catalog. So what you see on the top right, in this case, is about the spatial temporal coverage of the data for ECVs, so in this case, CI thickness. So it's just an example. And for each one of these information, there is written documentation, at the moment, mostly in PDF, being migrated in a bit more easy format to maintain for us.
5 minutes?
Yep. So a lot of this information is summarized in a sort of maturity metrics concept that we have readapted from the EO community to a wider set of data set. And as you can, this is in this case is for ERA 5 wind and pressure level. And as you can see, we are not necessarily kind to ourselves. And if you go a step further, and this some summary assessment, in this case for temperature ECVs, we try, or at least we have tried through this EQC exercise, to provide all the information to the user in a simple but transparent way. And it's very much what was said before, this hierarchical disclosure of information. So you can go a bit deeper if you want, but there is sufficient information at the first level to make you an idea of what we're doing. So let me skip this one. It's just another example of how we are using the data. And let's just go towards the next element. So the first one is that to implement these programs, this reanalysis, it takes time, as you know. So possibly something in the order of 8 years of R&D improvement to get to the next generation of reanalysis. And so we are very much looking at Euro 6, but a lot of the decision about Euro 6, not everything, a lot are still open, but the basic approach is set. So taking on board the comment from the user, definitely, but also taking on board all that is happening in terms of NWP, all that our colleagues have presented in the last few days. So you have seen this slide before, so high resolution, the coupled data simulation or the coupled system, the improved forcing data set. And we are already working in research mode in terms of improving the coupling also with land. So there is a research project that should be starting later this year, looking at land joint data simulation for land and possibly preparing the terrain for Euro 7. So I just want to put this alongside something else that is happening. So this is a sort of progressive, incremental improvement in the system. At the same time, we know that to crack some of the key issues of the simulation, then we need a step change in our computational capability. So what you see on the bottom, this nice animation, is the wind gust. The 10-meter wind gust is an animation done, I think, by Niels Veli at 1 kilometer, and you really see the impact of this resolution when you try to resolve the wind structure in the valley, in this case of the tip of South America. And so on the one hand, the resolution makes a big difference, as we know. On the other, the going to very high resolution also allows to resolve some of the processes that are not resolved by the resolution we are running now. So the Holy Grail, when I did my PhD, I think 10 kilometers was considered in the grain zone. I don't think anyone thinks 10 kilometers in the grain zone anymore. And this is pushing. But going to 2.5 kilometers or thereabout is possible. So this is just an example. One of the two is coming from a 2.5 kilometer simulation of IFS, and the other is a GOES satellite image for the same day. And it's difficult to tell the two apart. And again, this is about model realism, but it's also about a step change in our ability to crack some of these problems. And that's exactly what Destination Earth is trying to do. So in much better simulation, much more realistic model, combining all observation and simulated information, and in the future also in terms of impact in a system where through the digital twin, the user are no longer simply client or passive in the recipient of this simulation, but they can actually take an active role into that. So interacting with the system more directly. I'm speeding up a bit because I know that I'm running out of time. Let me just to get to the key point, because on one element was here the improved realism by increasing the resolution and increasing also the if you want the complexity of the system by reducing the reliance on parameterization and improving in general model realism. But the other is also that by increasing the resolution of the model, the data volume increases, and this was picked up in some of the discussion in the breakout session. So this slide actually comes from Bjorn Stevens, the MPI director in Hamburg. And the point here is that the future is hybrid in the sense that the physically based models are one of the components along which we can use a number of different tools, such as machine learning or emulator, to save computational resources, to reduce the data volume that needs to be stored and so on. And this, again, something that Destination Earth is actively working on. So the Destination Earth is a three-legged beast, so to speak. One part, the digital twin and the HPC workflow sits comfortably with ECMWF. But the other two, so the user portal and the user interface that is led by ESA, and the data lake that are and the data bridges are very much led by EUMETSAT. The two digital twins, so the extreme digital twin and the climate change adaptation twin, are being developed during this first phase. That is relatively short and should put the foundation for the following phase. So this is ending in slightly less than 2 years' time. So it's really putting the basis for the digital twin and demonstrating the new capability. The next phase is to develop further and fully integrate the impact element into the simulation. So that's where we are. As you have seen, I haven't mentioned reanalysis here because it's not immediately in the scope of Destination Earth. At the same time, as I was saying, Destination Earth represent a paradigm shift potentially, from which we can benefit in the future. So I conclude here with some take-home messages. So the reanalyses are indeed the basis of our service provision, and this goes beyond just the provision of data. It's really maintaining an operational system. ERA 6 will be an evolution of ERA 5, and taking on board the improvement and a lot of the innovation that we heard about in the previous talks over the last 2 days, but also the user feedbacks. There is something on the horizon that's Destination Earth that's just started a few months ago, and this will provide a significant change in the capability for high-resolution modeling, but also in the way the data can be sliced, analyzed, used, and post-processed. So we don't have a fully mapped path in front of us, but we do expect this to bring a lot of benefit to the next reanalysis, next probably thinking about ERA 7 or thereabout. I just want to leave you with this slide that was mentioned by Chiara on the first day, and is a special issue on the Journal of Meteorological Application that we are running, Chiara, myself, and Dick, on. So the deadline is in September, but the focus is very much not on the development of the reanalysis system, but much more on the use of the reanalysis in the context of climate services. So the call for paper is open. If you're interested, get in touch with us. Thank you.
All right, thank you very much. So before we move on to the general discussion, let's start with questions for Carlo.
Carlo, a very nice presentation. I'm Patrick Heimbach. I have a question. The Destination Earth stands for the Earth, and much of what I've seen so far focuses on the atmosphere. What are the plans within Destination Earth to really consider really a fully coupled Earth system that, you know, atmosphere, ocean, cryosphere, potentially the biology, at least marine biology, and or the carbon cycle? How much is that integrated?
Well, I guess what Destination Earth, and certainly Peter would be a better position to answer this question, but what certainly Destination Earth has managed to do is to put this new concept on the table. And some of the boundaries are not fully defined yet. That said, the aim is really to have a digital twin of the planet. And so by digital twin of the planet, it means considering also all the elements, so carbon cycle, ocean, cryosphere, and the like as part of it. Whether this can be achieved within the next 2 years, well, I would say probably definitely not. Whether you can achieve in the following phase after 2024, that's more the case. And a lot of the progress that can be made there depends on how much progress we'll be able to make over the next 2 years. I see the next 2 years to be very critical for Destination Earth, because the scope is absolutely massive, and the time is very limited, and there is so much to do. So I guess the answer is probably yes in the long run, but attaching an exact date to that is difficult at this stage.
Isla Simpson from NCAR. I didn't catch what kind of length of simulations is it feasible to run these digital twins for?
Say it again. What kind of simulation?
What kind of length of simulations are we talking about that it's possible to run this model at?
Yeah, so I guess the emphasis, well, the emphasis is really on the climate predictions, sort of seasonal to decadal kind of timescale, with a look at a multi-decadal timescale as well. The length of the simulation, I guess, will also. So at the moment, we don't yet have the new infrastructure, the new computer infrastructure. So this will the new pan-European computer infrastructure is only being developed now. So some of the run will be done on a new ATOS machine in Bologna that is not yet fully operational. So we don't yet fully know the speed at which this simulation will be running, which will constrain some of our ambitions. But we are talking about months to decades, if that makes sense.
Thanks.
Yeah, this is Patrick Heimbach again. I'm wondering from a way how you got the European community organized to rally around this massive endeavor, and in the context, for example, on the modeling. Is this sort of a path to sort of a convergence of a modeling effort to basically this one super high resolution model? Is this going to be just a sort of a, how you say, souped up ECMWF atmospheric model, or is this a souped up like climate model from the Max Planck Institute, or is it a completely new model that both or several people or entities will contribute to? And I'm interested in this, just really in the way of how are you managing to have different groups converge onto this type of development?
Yeah, and it's a very good question, and I'm sure that I'm relatively sure that Peter and I will probably have different responses to this question. My feeling is that what Destination Earth managed to do is to put the need for this step change on the map and attract the attention of the funders and the European Commission in particular, and this has changed the dynamic of the discussion somehow. Where this will lead, we don't know, to be quite honest. And in fact, what I was mentioning before in relation to the reanalysis, I think is valid for some of the elements of C3S as a whole. So we do see C3S as being very much user-driven and close to the user, and we see the benefit that this new technology and new paradigm will offer to it, but it's not clear at this stage when and how. So we see this as a massive and really exciting opportunity. And if you are in Bonn, as I am, seeing all these new scientists coming in with fresh ideas is fascinating. Whether this will become the new pan-European model setting for future generation, I think is a bit too early to say. It's certainly a major shift forward, and a shift that has received a lot of attention from the European Commission, from the policymakers, the funders, and in that sense there is strong momentum. But I think it's a bit early to draw conclusion on where that will what will be the future of it. For sure, ECMWF will take full advantage of what we learned through this exercise.
So let me broaden a little bit the conversation now and ask the audience here if there are actually questions that are across the different presentations that were in these sessions about collaborations, or if based on these presentations you have some ideas that are emerging in terms of avenues of collaboration in the future that you see we should really look into. Maybe a way to look at it is also to figure out what are sort of low-hanging fruits, or what should be prioritized in terms of where collaboration can bring the maximum benefits. We've had lots of discussions in the breakout rooms in terms of sharing data sets? Is that mature enough for sort of a wide variety of applications for various reanalysis use cases, or what needs to be done next, in terms of sharing data sets? Could we share other stuff? We've mentioned, production suites or monitoring, or having, shared tools for into comparison. We've now seen also how destination Earth can, potentially provide completely new avenues for reanalysis in the future to expand. So I'm just opening the floor here for reactions or ideas, and what collaborations should we try to prioritize, and what is needed actually to happen. And I realize we have a general conversation of collaborations just before break with coffee, so I know it's gonna be a little tough.
Sergey, Frolov, maybe that's a great segue to our breakout sessions, because that's exactly the charge for the breakout sessions to follow. But luckily I see that Bill Bell does have a response to your question, so maybe we should definitely listen to what Bill has to say.
Okay, Bill, go ahead.
Yeah, Tom, it's a really good question on the optimal nature of collaborations. My view is that on the data sets, you need to put significant investment into creating those quality data sets. But once you've done that, the sort of distribution and making those data sets shareable and open is relatively easy. The bigger task for collaboration, I think, is really exchanging the detail of the configuration that best uses those data sets. And for each and every data set, there is an absolute multitude of choices and degrees of freedom over how you exploit that data. And I think that's where the real opportunity is, to put in place collaborations that optimizes that and makes it happen in the best way possible. And I think the benefit for all of us is, as I said yesterday in my talk, it doesn't supercharge your developments, but it does accelerate them, and it does de-risk them. So that's I think that's the motivation, and the challenge is, what are the best channels for that collaboration? Do we piggyback on existing groups like the TOVS working group and the analogous working groups for RO and winds and precipitation, or do we start something different? I think there's a discussion to be had around that.
Well, that's an excellent comment, Bill. I think the sharing of the data set is just the starting point, but really the sharing needs to extend to actually how to exploit these data best, and that's actually, there's a lot of nitty-gritty details of how to do that in multiple ways. Another comment online, is that Carlo?
I didn't intervene before because I wasn't quite sure whether it was directed to the audience in the room or to us. So I stay quiet, but I completely agree with what Bill said. I feel that there are two elements of that collaboration, if you want to unpack it. One is a collaboration within the different entities involved in the generation of high resolution reanalysis, data simulation, capital model, and the like. And I think there is a lot that can be done there to improve things with respect to present. And the second one is very much what Bill was referring to, and what I was also mentioning in my talk, and is the collaboration with this growing set of users that have very disparate needs and different understandings. So I guess my plea there would be to say, really to listen to this, because there are a lot of elements that are not necessarily emerging from the conversation we are having within the science community, that can be actually very informative and very useful in shaping up the next generation of reanalysis.
Right, thank you very much, Carlo. So I don't know if there's anything else online I think it's about time to break out for coffee. We'll definitely get into more discussion about this topic during the breakout sessions at 10:40. So stay tuned and enjoy the coffee. Thanks to all the speakers. Okay, let's start wrapping up the meeting. We have 2 more items left on our agenda. We're gonna present a quick summary of breakout group discussion so everybody know what was discussed. And then we'll spend some time wrapping up, summarizing next steps and things like that. So I'll start with a summary of group 3. It seems like there is an interest in ongoing discussion of issues and opportunities for collaboration and coordination, maybe presenting current problems in different centers. So kind of an ongoing series of mini workshops, and it's either 1 hour once a month, or maybe a couple of hours every other month. And even though there is a formal WCRP group for some of that, not clear to me if we want to go the very formal route of a group that has membership, or if we maybe more beneficial to be informal at first, that we don't have to decide who is a member all in on or all in off. Nico, do you have some thoughts about that?
I guess there are benefits on both ways, right? I think through a formal process, can help to have the view from or by countries that that's something that is internationally coordinated officially in that sense. For the informal mechanism, sometimes maybe faster in the sense, because then it becomes a personal relationship, right? Because you know the person who is working with you. But like I said to many people, I have some homework. I have some homework to do once I get back to the office to get some of the groups that exist already, like the intercomparison reanalysis group, to try to reinvigorate those things that these mechanisms can facilitate, I guess, this kind of discussion. There's always a way to be less formal in the sense, I mean, formal but less bureaucratic in terms of membership of groups and so on, right? So I think we need to brainstorm a little bit, but to get the benefits of both ways to do it. The international coordination always helps countries to get funding, for example, in that sense for new activities. So,
okay, that's actually a great second point. That at some point funding for these activities becomes important. So WCRP can help people meet face to face maybe once in a while. Another opportunities follow maybe a lead of some previous intercomparison projects. Patrick, do you want to share? So you were involved in previous intercomparison. Was there any formal funding attached that helped people to coordinate? Did they just like applied for the independent funding sources? Do you want to use a microphone?
As I recall, there were funding to meet, right? So for regular meetings, there was. I don't think there was any at least at US level. There was no funding support to conduct these experiments. So it might have been different at the European level. So I think it was really grassroots efforts where people basically on the side try to basically do these things.
So in terms of sharing, we have discussed that, a lot was built up on what Bill was saying earlier, that, we can share observational data sets and share information how to use these observational data sets, including black lists, white lists. And these, regular meetings can help to actually sort out a lot of logistics of what that sharing might look like. One thing that was brought up that we really want to share observational feedback, but it has, when people tried it before, it was impractical because it's very large and has restricted data in it. And a good way to do it is to share some aggregated observational feedback. And European Center has some ways to aggregate this observational feedback right now. And we might be able to follow the lead into what kind of aggregates, appropriate aggregates. But a clear need that we should speak to agencies is to find a way to share this aggregated feedback across centers independent of the specific formats used in each center. We also discussed that it's really helpful to focus discussion if you can focus on the specific problems you're trying to address at the same time. And they include introducing new free processes data. So, for example, when Bill said that there is a historic satellite that they rescued, how we're going to use it, what are QC procedures, things like that, lessons learned. Dealing with artificial jumps in the mean state is a big problem that everybody is concerned about, and we can formulate a sequence of experiments that people can follow and, pick a same year, and maybe we say, like similar to what Patrick was showing, that we remove all stratospheric observations and see if we can deal with that. So developing protocols like that will be one thing. So characterizing uncertainty with respect to transition in the observational system, that's another great example. So we can, for example, artificially remove an observational system and see if our uncertainty estimates actually can characterize these artificial jumps appropriately. Understanding what we mean by real uncertainty for the mean state, that's a great example of we're having a regular meeting where we have discussions of how we go, what do we mean by that? And exchanging ideas is another great example. For QC procedures, I did float suggestions that JEDI can be a good mechanism to actually articulate what QC decisions are made. Unfortunately, that idea was a little bit shut down because a lot of these decisions are very system specific, and it might not be practical to have a generic QC procedure without going to details of a specific system. So I think that's all that my group had, and if people want to. Any questions to my group? If not, I'll put Ayla on the spot.
Yeah, I think we had quite a lot of overlap with what Sergey said, but maybe a few differences. So we thought we need a more formalized dialogue between the different agencies. Right now, I think it's individuals a bit ad hoc getting together and talking about things. Like Sergey said, I think we discussed how a really fruitful thing to do would be to coordinate within the US about observational inputs and have some formalized way of gaining the knowledge that each center gets as they realize issues with the inputs and the best ways to use them. And we had some discussion about whether this should be an international thing. And I think it was considered that first the US needs to get themselves in order, and then it would be more fruitful to collaborate internationally. We talked about reanalysis intercomparisons and wondered if there should be more of them. And I think this was considered that this will be useful as we get to the new kind of coupled reanalyses. But also we need to be clear that there's a purpose and then it's not too much of a burden on people's time to be running extra experiments and things. We discussed that there could be a process for broader engagement with the user community so that they could have a more formal way of providing input to the process when new reanalyses are created. And apparently this was done for MERA, but it wasn't done for MERA 2. And this will be really important as we start to have all of these other components within the reanalyses where you need this extra knowledge from a broad user base. And then for coordinated experiments, I think this is maybe a little different than the ones that Sergey listed, but that as we start to have all of these different components and complexity and expense, then there's like a lot of kind of ways in which this expense could be limited, but I think some experimentation is needed to know what is optimal, like coupling frequency or the frequency of assimilating the observations. And so maybe while some things could be specific to the systems, there's probably some things here that would not, and if could kind of spread the load in doing this kind of investigation into what's optimal across the different agencies. So that's all I managed to write down in a couple of minutes. I'm sure I missed some things. Maybe others can chime in when we go to the discussion. Shall I go to, okay, group 2.
All right. So we also sort of frantically put down some notes that I sort of pulled out as what really we highlighted in our group, but we talked about a lot more than this. So first, we also talked a lot about reanalysis intercomparison, and one of the things we focused on is the need to establish a set of metrics generally, but we talked about establishing a set of independent data sets that all the different centers could use for validation. But really that goes towards having a set of common metrics, both for performance and uncertainty quantification in order to assess the significance of differences. We talked about a suite of metrics that could include things like fits to observations, but also climate indices, and this is a little bit more broad, but how well each reanalysis estimates unobserved variables, or each center's system does these things. Maybe analysis increments, and maybe things like forecast sensitivity to observation impact. But efforts like that have been tried. It's difficult to make apples to apples when you have different data assimilation systems. We thought about looking at what metrics CMIP uses, but haven't actually done that. And as Sergey mentioned, defining specific years if we wanted to do something like that, make sure each center is running the same year, for instance, so that we have at least sort of similar observations that each system is using. We also discussed the need to determine the motivation for individual centers to participate in collaboration. One of the main challenges for this is that as centers are making reanalyses, they're all on different time schedules. And so getting two centers at the same time period, even if they're on the same time period, to collaborate is going to be difficult. And the motivation could be that if you are able to leverage others' work to help solve problems that you run into, for instance, if they've run into a similar problem, then that could be motivation. But in order to do that, you need to understand their configurations. And again, I think having the same metrics is really going to be, would be necessary for that. And then lastly, I sort of wanted to mention shared infrastructure just as a method to push collaboration. For instance, JEDI, you'll avoid a lot of the challenges that come up at step 0, having data in the same format, access to the same diagnostics, and you could easily see configurations of different centers. And so we talked about a lot more, but those were sort of the 3 big things that I mentioned. And so I guess I don't know if we have time for discussion, or I don't know who's taking over at this point. Any questions on this for now?
I think we have 25 minutes for discussion and wrapping up the workshop. If Sergey, you're leading.
Yes, thank you. Okay, I will go to some generic slides right now, so we're not distracted by any specific text. Here you go. I think I want to start by making sure I thank everybody who dedicated their time and effort over this workshop. I want to first thank US CLIVAR who supported this and help us to actually organize ourselves to run a well-thought workshop.
Say a lot of people in the room,
But can you
them over these couple days. They've steered us over the course of what, a year and a half on monthly meetings. So you guys have been great.
Yeah, we specifically wish best of luck to Jenny, who is going to take a new position as of next week.
You guys know I love working with all the scientists. Yeah, my last day with US CLIVAR is on Friday. So this was my big last hurrah.
I want to thank people who came in person, that took an effort, and you dedicated your time. And for some of you, it's a this Reanalysis effort is very central to what you do every day. And it's was an obvious thing to do. But we also have a lot of people in this room who are kind of, somewhat related to the Reanalysis effort, but they still did a honest job of putting intellectual effort into it and contributing. So I would like to thank them for that as well. I'd like to thank our European partners who also put a lot of effort into supporting us through this intellectual discovery. It's very focused on what we're going to do in the US. The next steps will be very focused on what we do in the US, but we'll also project into, what we're going to do in collaboration with our international partners. So with that, maybe I want to ask Hans to give a couple of remarks what he found useful through this exercise.
Thank you, Sergey. So yeah, I found it very interesting to attend this meeting, and of course I wanted to know what the different activities that are taking place for Reanalysis in the US, but also what you're up to for the future, because that's what the title of the meeting was about, and also what kind of problems you have and whether they're similar to our problems and how we can solve them together. And I was also very interested to learn a little bit more about JEDI and how that could also, because you standardize the way you ingest and use data and do data assimilation, but of course that facilitates also for you to work together, isn't it? And in general, interest to talking science and common problems and learn from each other. And of course, to see several of you that I haven't seen for a long time, seeing them. And yeah, so I found it was a very, very interesting experience for me, this workshop. And of course, what to show what we are doing at ECMWF, not only like the production of Reanalysis, but also the whole other thing around it, how we listen to our users, how we respond to user queries, things we didn't talk about user engagements, these kind of things.
Yeah. Thank you, Hans. Is there anybody left from Copernicus program who might want to make some remarks of how they found this workshop useful to them? Okay, sounds like our Copernicus partners took off and are picking up their sons and daughters from daycare right now. I also want to ask Cecile, who was she is chairing this meeting together with me, but because of her childcare responsibilities, she finds it more convenient to attend remotely. And we're in this world of hybrid meetings. And Cecile, is there anything you want to share about how this meeting went for you?
Now, I want to really thank everyone who participated. I know there's a lot of people from everywhere that have participated online and in person. And I think if some COVID has taught us something is that hybrid meetings are going to be more and more common, and we can be effective that way. I think from a more, not end users, but probably more of the extreme side of things in terms of being in the ocean biogeochemistry world, I think this kind of meeting where we mix up climate modelers and Reanalysis producers and we start the conversation is extremely important, and that's where the future is, I think. Meetings and a working group where we're going to have all the parties represented and we're going to talk together, I think is extremely important. And so I hope this is just the first step of many efforts to go in that direction. So, and of course, thanks Sergey, who did a lot of the work in leading the effort along with US CLIVAR, Jenny, and the other people on the organizing committee. I think it was a great experience, and I was really glad to be part of that. So thanks, everyone.
Thank you, Cecile. So in terms of the next steps, there are a couple of, well, there are mandatory steps we need to take. And there are steps that I think kind of extend it beyond what we have to do. So the mandatory step, we need to write a report. And we will debrief this report at a couple of levels within the US. So the first level will be program managers who sponsored that meeting. Mike, do you want to mention what is the scope of that program management committee who actually sponsors this meeting? Here our first debrief.
So listed here are 3 agency sponsors. That includes the NASA Physical Oceanography Program, the NOAA MAP program, that's Modeling, Analysis, Prediction, and Projections, as well as the Climate Variability and Predictability program there, and then NSF, both its Physical Oceanography and Large-Scale Climate Dynamics program. So we'll be briefing out the full interagency group, which includes additional managers from Department of Energy and ONR, as well as some other programs that didn't provide the funding here, but notably those modeling programs like MAP at NASA. We'll want to be sure to include them in the briefing. So that's at the program manager level. But some of the ideas that have been surfaced here, I think will benefit from going a bit higher within the agencies to, so there'll be a report, but extracting from that report, perhaps an initiative that agencies might be able to sell and garner resources to put the US on a more stable footing with regard to support for reanalysis, as well as data assimilation and even our prediction efforts, and packaging things in such a way, as the Europeans have done so well, to sell the bigger thing, right? And thereby support these activities that underpin our ability to analyze and predict climate. So I didn't mean to step on your the second part. There will be later briefings of the agencies at a higher level as well.
And thank you, Mike, you did a better job describing it. And I think the timeline is that the first briefing probably will be sometime in fall, and the second briefing probably be after the New Year's. There were a couple of things that when we draft the report over the next few months, there will be iterations within the SOC, but then we'll also reach out at some point to everybody who participated for feedback. At some point, that report might be redrafted as a BAMS article, as a vision statement, but that's the lowest on the priority list right now. There are a couple of things, I think, that became so obvious through this workshop and through preparation of this workshop that it will be like, why wouldn't you do that? So I think that we should look together with Nico into how to reestablish some standing international meetings, and thinking about it a little bit more. Maybe it's a combination of an informal meeting that runs more freewheeling and has some rotating chairship from different centers, and some more formal international coordinating group who can sponsor meetings or provide high-level cover for us, let's put it that way. Another obvious thing that was everybody kept on mentioning was collaboration and observational input. And another thing that became obvious that it's not just observational input, but things like emission databases, land cover databases, things that you need to run a credible reanalysis effort. There is an ongoing discussion and a NANSEN effort funded to do it between NOAA and NASA, and we'll try to grow it organically. And we will, once we have a specific target, we'll definitely reach out to European Center for feedback. Is that something that will be useful to them, or how we can enroll them into this collaboration? Another effort is to share observational feedback, share these metrics. So in this context, maybe an appropriate thing to do is through this informal meeting, actually formalize a set of metrics we all agree are good ones to look at to evaluate quality of reanalysis. Are we progressing through a set of experimentations? So that will be something we can work maybe this summer, maybe fall when everybody returns from traveling. And yet another thing to do is as part of preparing these reports, we'll probably be reaching out to our European counterparts to better understand, because you guys are so well organized in your funding structure, you actually can tell us how many man hours or person hours it takes to achieve certain capabilities, what kind of compute budgets one has to plan to produce things like ERA 6. And that probably will be part of the briefing to the agency higher-ups. I think that's kind of all obvious efforts that I could identify as the next steps. Anybody is willing to step up and suggest anything else we should do? Ron?
I'll embed that in the last thing. I just want to say a couple things. First, I want to also thank you, Sergey and Cecile, for chairing this thing and organizing it for the committee. That's been great. It was really a great experience to be here with a lot of people who I don't ordinarily talk to, and different components, different uses, and that's, you can get very tracked when you're, a reanalysis producer of a certain type and whatever. So that's been very eye-opening, and hopefully we'll take some of these things to heart and make sure they get incorporated. Leslie and I work very, in the same building, a few hallways away. This is by far the most conversation I've had with Leslie probably we're on the management team together, but, about this sort of topic. So it's just been a great forum for that. And I also really am impressed and want to thank our colleagues, our European colleagues, and like you said, how much they invested in helping us here and staying on and really sharing things. And that's where I'll sort of get to the next point, which is the other thing that I learned, particularly from, I guess was talk today, along the lines of the investment in compute and things like that for ERA 6, the just incredible effort that, Copernicus has made that I think we should try to emulate in organizing, formalizing the process for taking in user requirements, letting those inform the process of the reanalysis production. I just think, that has to be something where I know we've not really invested in that. And I think it would be great to emulate some of the things that they did in terms of formalizing that process. What was the overhead for the cost of that in Copernicus? The kinds of things that were spoken about today in that talk. I just think that would be tremendously useful before or as we embark on this very costly thing to make sure it's going to be useful for people, and that then as we go, we have ways of informing and changing that, decision-making process. So I think that aspect of the user engagement and formalizing that and investing in that will be critically important. So that was something, in addition just to having great colleagues show their stuff to us, it just, wow, yeah, that's a component we need to really put up front.
Mike, you wanted to say something?
So another follow-up, we'll be sending out a survey. So this is our 6th hybrid meeting, our 2nd here at UCAR in 2 weeks. I've been talking with the enterprise IT staff here about how the setup here actually for the ones that we've held has been exceptional, with the additional screens here for us to see the people online, and then the large screens for seeing the presentations and their ability to support a more seamless experience for those of us in the room and those online, bring us together truly into the same meeting. So I do want to also recognize Kendrick. Is that right?
Kelvin.
Sorry, Kelvin, sorry. And help me out.
Reed.
Reed and Kelvin, who have been here throughout the 3 days to help us do this. As well, I want to say that we're the first such community activity here in UCAR facilities. There will be a later one this week that WCRP is putting on up at the NCAR Mesa Lab. And the catering was also a concern as they've started to hire the caterers back. And so I want to also thank our catering staff here that have helped enable us to have the meeting, because without food and beverage, we would have not been able to have it here. So I want to thank them as well. And then, and as well, the support that we got from UCAR community programs, again, giving the name, Jetty, of the people who were out front.
Aaron?
Yeah, Aaron, who helped us with door monitoring, this being the first time we've had a facility door open and accessible. So, so this was a team effort within UCAR, and which we sit, US CLIVAR Project Office sits within. So I really appreciate all the support we got from the organization. Also, I want to lend my voice to thanking our co-chairs. Cecile, if you can come back on screen. And then I also want to recognize all of our members of the SOC. This has been really a terrific effort. The commitment of their time over the last year and a half, having to deal with the stall out of when we were going to have the meeting and then the restart, and the energy that they were able to build to bring people here and online. So I do want to thank the people. And I'll stop there.
I guess especially special thanks goes to Dick D, who is not here. He's not enjoying the joy of seeing colleagues in person. He's enjoying spending time with his family and his 90-year-old mom. So one more special thanks. Is there any final comments, remarks? Well, with that, I'll hope to see you in the future. Thank you very much for a great meeting, and enjoy the rest of the day.